In this tutorial, we're just going to go over the intermediate value theorem. So it's a very simple concept that is going to help us even review some few questions to help us understand everything. Okay, so the basic idea is you need to have a function. So let's say we have a function f of x, and then this should be continuous on a certain interval, let's say a and b. So that's the first thing that it states. And then we also need to understand that the function of a should be what? Should not be equal to the function of b. That is second. What is the other thing? The third thing is, if that is true, if all these two conditions are met, one, it is continuous on that given interval. Secondly, the function of a and is not equal to the function of b. What does that tell us? So that tells us to say that we are going to have a case where the function of a is less than a certain value k, and that certain value of k is going to be less than the function of b. Okay, so of course, as we can clearly see, it's going to make sense as we put it on a graph. So now let's try to think of a graph. So on a graph, what that would imply is something like this. So let's say you have a certain graph. This is your function. Okay, something like that. And then we get to say this is our a and then our b. Okay, let me do this. So let's say this is our a and then this is our b. So what can we see? First of all, we can see that first of all this function f of x is continuous. So first of all, it's continuous because there is no point where it is discontinuous. So there's no point where we have an asymptote. Okay, so examples of functions that may be discontinuous are functions that have such a point. Okay, or maybe you can have piecewise functions like this, and then there's another one that's going the other side like that. So those are examples of discontinuous functions. So at that point where it is discontinuous, this theorem doesn't apply. So we are focusing on this kind of a continuous function. And then what are we saying? So we've noticed first of all again that the value of the function of a, which is somewhere here, so that is a function of a, and then the function of b is somewhere there. So what are we saying? So we are saying f of a is not equal to what? Is not equal to f of b. That is the second condition which has been met. So in this case, we can now apply the intermediate value theorem. So what it tells us is say there is a certain value k. Okay, so there's a certain value k which is supposed to be in between. So for example, at any point that we decide to choose, so if we draw a line there, so that tells us to say that this is a certain value k. Now that gives us a certain point c. That's what we are trying to say. So we are saying f of a is less than a certain value of k, which is less than a certain value of the function of b. So now that k is basically equivalent to a certain value of what? A certain value of c. So this is a very simple concept which tells us to say if you have two values a and b, of course you have a function continuous on that interval, you are able to find a value in between the two values of y, which also give you a value in between the two again on the x-axis, as we can clearly see. Okay, it's very, very simple. Now, how can you put this in application? So we are going to use this basic idea to help us get to determine or approximate the values, okay, the roots of functions. So one way that we can think about it is a case where we have this kind of a function. So if you have this kind of a function, and then let me just extend the y-axis on the bottom. So if you have, this is your value of a, and then you have a certain value of b somewhere there. What can we see? So this is our a, then that is our b. So if I draw there, I'm able to find my value of b, the function of b, that is, and then the function of a is at this point, so that is the function of a. So first of all, we've noticed that between the range of a and b, this function is continuous. And then we've also noted that the function of b and the function of a are not the same. So this can help us by looking at the way these are. If you look at the function of b, the function of b in this case is what? Is positive. The function of a in this case is negative. Okay. So if this is the case, and then we are also saying the function is continuous, what it tells us to say is there is a certain value in between the two. Let's say f of c, where it is going to be equal to 0. And that is true, as we can clearly see. For us to have this negative and that positive, as this function moves, there is a certain point where it's cutting what? The x-axis. So we are going to be using this basic idea to answer the questions. Okay, so this is what the intermediate theorem is all about. Now, question 1 is asking us to show that the following equations at least have a solution in the given intervals. Okay, so now what are the given intervals in this case? Let me just show the intervals. So the first interval is between 0.2 and 0.3. So what are we supposed to do? So it's all just takes us back to the idea of showing that the function of a certain point is going to be negative and the other side is going to be positive. And the fact that this function is continuous will also tell us to say it's going to work out. Let's try it out. So I'll start first of all by trying out the smallest value. So I'll say the function of 0.2. So look at the given function itself. Substitute. So you have 0.2 cos 0.2 minus 2. So where there is x, we'll put 0.2 again, squared, plus 3 multiplied by 0.2, and then we have minus a 1 there. So grab your calculator and perform the calculations there. So 0.2 cos 0.2 minus 2 multiplied by 0.2 squared, plus 3 multiplied by 0.2. Minus a 1. So the value that I'm getting is negative 0.28. So take note of that value. Okay, so that value is giving me negative 0.28. So we can now also move to the other part, which is a function of what? A function of 0.3. So you will do the same. Just change where there was 0.2. Try to put 0.3. So 0.3, 0.3, and then we try to see what we are going to have as a solution. Okay, so on my end, the answer that I'm getting is 1.012. Okay, this is what I have. Now, the basic idea is if you get back to your graph, you draw it like this. This is your graph. And then what you have is two values of a function, of course. So, of course, let's assume this is where 0.2 is, and then approximately what is where 0.3 is. So 0.2 is giving us a negative 0.28, which implies it's somewhere here. Okay, so we have a certain value there. And then 0.3 is giving us a 1.0 something. So assuming that this function, of course, as we can see, this function doesn't have any asymptotes. Okay, so it's continuous. So that function is going to be continuous. And since it's continuous, this tells us to say that there should be a point where it had what? Where it had cut the x-axis. And that is a solution to the given equation. So what is the basic idea? So if you are able to show that one side is positive and then the other side is negative, and also the function being continuous, then you're able to show that there is a solution existing between the given interval. So all we are using is the intermediate value theorem to get to show our solution. So feel free to pause the video and just try out the next one so that you see what you're going to have. So now let me just also show the intervals as well. So the interval is between E and 4. Okay, that is the interval. Feel free to try it out. So let me just create some space. Okay, so I'm assuming you've already tried it out. So let's try to solve it together. We see what we're going to have. So obviously, we need to just use the given values there. So looking at the function itself. So for the first one, we have e. So I'll put e, where is x minus 2 to the power 2 minus natural log of e being equal to 0. Okay. So forget about the equivalent part. We just need to focus on this other side. So if you look at the value of e, it's approximately something like 2.718 something. So if you get to subtract that by 2 and then square it, approximately value that I'm getting is a 0.516 minus, so of course the natural log of e is just the 1 since these are inverses. So what you're going to have is negative 0.48. So that is what the value of e is giving us. What about if you try to put a 4? So if you try to put a 4 there, it's going to be 4 minus 2 squared minus the natural log of what? The natural log of 4. So 4 minus 2 is a 2, so it is 2 squared minus natural log of 4. So now, what is it going to give us? So 2 squared is 4, and then the natural log of 4 is what? 1.38, 1.39. So if you subtract the 2, approximately you're going to have a value of 2.61. Okay. So what can we see? We can see that first of all 1 is negative, and then the other side is what? Is positive. And this function doesn't have any point where it's discontinuous. So that tells us to say that there should be a value that lies what? That lies between this value and that value, which is approximately going to be a 0, which gives us to say there is a certain point C in between where the function is equivalent to 0. Remember, the basic idea behind the theorem was if you do have a function continuous on a certain interval, and then the function of the 2 points are not equivalent, as we can see, the function of e was not equivalent to a function of 4. And then you also say the function of a is less than a certain value of k in between, and then that certain value of k is going to be less than the value of b. Okay, so we said there should be a certain value in between, which is a k. So in this case we are saying it's a 0. The idea that the fact that this one is negative and then the other one is positive tells us to say that there is a 0 in between the fact that this function is continuous. Okay, so that tells us to say that there should be a solution in between, because this k is representing the value of y. Okay, so we have another question which is asking us to find the intervals instead. So we've been given certain functions here, so find intervals containing solutions to the following equations. So we have equations that we may not be able to solve directly. So I'll write the first one, which is just x minus 3 the power negative x being equal to 0. That is our function, our equation. So how do you get to guess? So we're going to use the intermediate value theorem to just help us as well. If we're able to find 2 points a and b where f of a may be negative and then f of b positive, then we are very much sure that in between these guys, given that these functions of course being continuous, tells us to say, or assures us to say, there is a solution in between where the function is equal to 0. Okay, so feel free to try out any values. So first of all, start by trying out 0. We see what it's going to give us. So f of 0, so that would mean that we have, where there's x, we put a 0, so we have 0 minus 3 the power negative 0. So negative 0 is just 0. So what does that give us? So that gives us negative 3 to the power 0. And then you do know that negative 3 or any number is to the power 0 is just the 1. So in this case you have a negative 1 for f of 0. Okay, so we have a negative solution there. What about f of 1? What about if you try f of 1? What is it going to give us? So trying f of 1, we're going to have 1 minus 3 to the power negative 1. Well, we do know that any number is to the power negative 1 is the same as uh, 1 over that. Okay, the same power 1. So basically, if you get to subtract 1 minus 1 over 3, as you might expect, it's supposed to be what? 2 over 3, which is obviously what? A positive result. Okay, so this is a positive result. This is a positive result. This is the negative result. So we are very much sure of the fact that this function is continuous. We are very, very much sure to say there should be a point where there's going to be a 0. Okay, so therefore we can show the interval to say between 0 and 1. The fact that 1 is giving us a negative and 1 giving us positive, and the function being continuous, assures us to say there should be a solution in between the two functions or the 2 points. That is how you get to answer these questions using the intermediate value theorem. So if we move to B under question 2, so you can come up with an interval and then just try and see what you're going to have. So I can decide to start from negative 3, and then we have negative 2, negative 1, 0, 1, and maybe up to 2. And then we'll try it somewhere in between. So the first trial that I'm going to make is between negative 3 and negative 2. We try to see if we're going to have the same sign. So if I try to substitute negative 3 in that given function, what do we expect to have? So that would imply we're going to have negative 3 to the power 3 plus 4.001, where is x, we put negative 3 squared plus 4.002 multiplied by negative 3 plus 1.101. Okay, so let me just plug that on the calculator. So you grab your calculator and then just try that out. So that plus 4.001 and then plus 4.002 plus 1.101. So I'm getting a negative value, negative 1.896. So take note of that. That has given us a negative value. So all the same, try out negative 2. Where is negative 3 at every point? Try to put a negative 2. We see what we're going to have. Okay. So negative 2 cubed plus 4.00001 squared plus 4.002 multiplied by the same negative 2 plus 1.101. So I'm getting approximately a value of 1.101, which is a positive value. So the basic idea is we do know that polynomial functions are continuous, and it being continuous and then one being negative and then the other one being positive tells us to say that there is a value lying in between these which is greater than this and then less than the other value, which of course giving us that 0. We do know that 0 lies between what? A negative number and a positive value. So that is where a solution is supposed to lie in this case. So we're very much sure, very much certain that between negative 3 and negative 2 there should be a solution to this function. Okay, so of course you can try out other solutions, try and try to find other solutions. Okay, so for your own comparisons, in case you are done, the expected solutions that you should have on that interval, apart from negative 3 and negative 2, between negative 1 and negative 0.5 there should be a value there. Between negative 0.5 and 0 there should be an answer as well. Okay, so these may not necessarily be the answers, just because, for example, this is somebody says talks about 2 points again that are in between, let's say approximately we can say maybe negative 0.9 for example, and then I say up to negative 0.5. that's fine. Okay, that's still fine. But the basic idea is these are simpler to write, so work with in betweens, 0.5s, and also the actual integers as well. So that's it for this video. I hope you now know how to approach questions using the intermediate value theorem and also understand what it talks about. Thank you very much for watching.